All right, hey guys, we are going to look at expanding what we've been doing with solving systems of equations. Everything we've done so far has been lines. Do they cross? Are they parallel? Are they the same line? And then finding the point where they cross. But since we are smart people in pre-calc, we know that there are things that are not lines in math. And we're going to be looking at ways to solve what we call non-linear systems. So they could be parabolas, circles, sometimes lines, but just expanding from just simply lines. So this is going to go with your day one worksheet. We're going to talk about substitution. And we're also going to talk about graphing. Now, sometimes graphing is super easy because you just type it into your calculator and it does all the work for you, but that won't always be an option. And so we're going to look at both. And then in your homework, I believe evens and odds is how it's split. I don't remember which one's which, but one of them you'll do by substitution and one you'll do using your graphing calculator. So first of all, this top part, and I'm just using this worksheet as kind of notes to show you some examples so you'll be good to go. The first system that we're trying to match, you have to kind of use your brain and think about things you've known from the past, like the fact that x squared minus 4 is going to be a parabola and it's going to open up, whereas this is going to be a line. So I start thinking, now I'm looking for a parabola and I'm looking for a line, which is not helpful because all of these have both those things. Then I can use some common sense in terms of this. mx plus b, this is going to go downward. It's going to cross at -2. So looking around there, these three all go up. So I'm already kind of thinking that A goes with A. But let's expand that a little bit more and take a look at how are you going to actually solve these using your calculator. For graphing, you're going to go to y equals, and you're just going to type in the first equation as y1. So x squared minus 4. Then I'm going to go ahead and type in negative x minus 2. And I think I probably had my graph set funny, so I'll go ahead and do, zoom 6. Pardon me. Hang on. So whenever yours is zoomed in like this, you can go zoom 6 and it will reset if you want to go back to regular graphing. Sorry, I have a bit of a glare. There we go. So I can see that that does indeed match with A, but more importantly to what we're going to be doing today, I need to know where exactly those are crossing. So I'm going to use the second function on my calculator, and then I'm going to go to trace. And under there, I'm looking for where they intersect, so I'm going to choose intersect. And when I do, it's going to go back to the graph, and you'll see up here, it's showing the first thing that I typed in, the x squared minus 4 from here. And it's asking me, is that the first curve? Your calculator doesn't understand. It only calculates. And so it doesn't know if you have 2 things entered or 10 things entered. So it's going to ask you. Now you want to get closest using the cursor to whichever intersection point you're looking for. So I would scoot over here and then I would hit enter because that is the first curve. Then it switches. Is this the second curve you want me to look for? Yes, again. So enter again. Do you feel like guessing? Heck no. So I hit enter a third time. Then across the bottom, I can see that those two cross at -2, 0, meaning that's one of my solutions. So if I put a -2 in here, squared it, subtract 4, I'd get 0. If I put a -2 in here, I'd get 0 as my y as well. But you also can see that this has 2 solutions, which is something that hasn't happened with the line. So I repeat my process. Second trace, intersect, but now I'm going to scoot myself over so I'm closer to the other one because it will find the closest one. Enter, 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 and it tells me that the other place that they intersect is at 1, -3. So I know that these 2 points of intersection or solutions are at -2, 0 and 1, -3. So solving this way can be really easy. Sometimes the graphs get out of hand and it's tricky to find them. And then with the matching here, you can just kind of use what you know in terms of graphing. So I know this is a parabola. I know it's opening up because that's positive. Here's a line, slope of +2, crossing at -2 on the y-axis. So this one's going to be, well, these all have those same features. This has a y-intercept of +2. This one obviously doesn't. This appears to have a y-intercept of 1. This looks like it's probably going to be my closest bet. But again, I can go ahead and just enter them in. So I'm going to type in x squared minus, and most of what we're going to be doing is not matching anyway. And so I'm going to need to learn how to solve them rather than just match them. So now again, if I go to graph, I can see that, yep, it appears to be matching with C. Now what's tricky about this is these just graze each other. We call that being tangent, where they just barely touch. So this will only have one point of intersection. And so when I go to second trace intersect and I try to get close to this point of intersection, and I hit enter a couple of times, it eventually kicks out the values. Now you can see here it's a little bit wonky. 1.9 repeating is going to give me a 2. 1.9 repeating is still 2. So sometimes it presents your answers kind of weird. But if I use 2's in here, I'd get a 2. If I use 2's in my x's here, I'd get a 2 for y. So this one only has one solution. That's the only place they touch, whereas this one had 2. If I move on to option C here, and I clear out what I've got, and I'm going to put in my x squared plus 1, and then put in an x minus 1. So again, a line and a parabola. When I hit graph on this one, it looks to be matching with B, but more importantly than that, they don't intersect. And because they don't intersect, that means that this one has no solution. So we used to have that option when we had parallel lines. Same thing here. If they don't cross, they don't have a solution. That's the entire point. So then in part D, and I know you already know which one it is, but for in terms of finding the actual point values, let's run through that one more time and then we'll move on to substitution. Okay, so if I entered in an x squared minus x minus 6, and then I put in a 2x minus 2, I'm looking at this parabola because, see, keep in mind this has, this has a -6 for the y-intercept, which is why this one is so low. This one's going to have 2 solutions. So again, second trace intersect, and I want to move my cursor closer to one than the other and run through my enter, enter, enter process. That's telling me -1, -4 is one of my solutions. And then the other one, second trace intersect again, zipping over closer to this other one so it can find it. I'm going to go through enter, 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 and that one is at 4, 8. So super easy to use substitution as long as they are written in y equals. So that's going to be the catch as we get into other methods where we can't get it into a y equals form. So therefore we can't use graphing very easily. Okay, so let's talk about the substitution method. You've used this before with linear, so the method isn't different. It's just that now you have to be considerate of the fact that you might actually have 2 solutions and remembering how that's going to appear here. So in this first example, it's pretty easy. They gave me a y value, and so this is going to be a line. If you kind of think, this is going to be a parabola, x squared plus 9, and this is actually going to be a horizontal line at 9. So we're solving this one by substitution. And so what I'm going to do is, since this tells me y is 9, I'm going to go ahead and substitute that into the next equation. And so this one's kind of weird because when I go to solve this and take away the 9, I get that x squared is 0. And when you square root, normally you have to do plus or minus, but there's no such thing. And so in this case, I end up with an x of 0 and a y of 9. Now, these are both in y equals, so if I wanted to, I could pretty quickly check this. Now, obviously, you could solve this using graphing as well, except that you're going to be handing in work to show that you did substitution on problems just to practice that method. So there's my horizontal line, and my parabola is actually going to be way above that, so I'd have to zoom out to see it better. But it's sitting right on there, and the only point of intersection that they have, and therefore the only solution, is 0, 9. All right, let's try one that's going to be a little bit less strict, like obvious. It doesn't tell us one of our solutions. So again, this looks like the easier thing to plug in, or in this case, the y's are both equal. So I could just say, okay, -5x has to equal x squared minus 3x minus 3. So this is going to unlock that good algebra 2 part of your brain because we're going to be solving a quadratic. In order to do that, I need it equal to 0, so I'm bringing over the -5x, and here is where I land. Now, at this point, you're either going to need to factor if it's factorable, or use quadratic formula if it's not. And that's where our potential for 2 answers comes in. Here, can I factor this? Can I find 3 in a way that subtracts to be 2? Yes. 3 times 1. When will it give me a positive 2? Plus 3 minus 1. But I'm looking for those to equal 0, so this will only equal 0 if x is 1, and this will only equal 0 if x is negative 3. All right. So at that point, I know that I have 2 answers, and for one of them, the x is 1, and for the other, the x is negative 3. And then to find my y's, I simply plug them in. I could plug them into either of these, but I'm choosing to plug it in here because that's significantly easier. So this is going to be a negative 5 when x is 1, and this would be a positive 15 when x is negative 3. So I could graph both of those and search around for those 2 points, but I'm pretty confident those are my correct answers. And so those two, this line, this parabola would cross in that manner. Let's tackle another one for better examples. Once again, this y is a negative 3x squared, so I'll put that here. And then that's going to equal 6x plus 3 because I'm substituting that in for the bottom y. Again, I need everything on one side, and I don't like my x squared part to be negative, so I'm actually going to add that piece to the other side. So 0 will be 3x squared plus 6x plus 3. Well, all of these have 3's in them, so I'm just going to divide everything by 3. When you divide 0 by 3, you get 0, but then this becomes easier to work with. Here I need to find 1 in a way that adds up to 2. So I'm going to have x here and here. To get a positive 2, they'll both be plus. In order to equal 0, though, sorry, I'm out of, there you go. My x's would have to be a negative 1 here and again here. So what that tells me is that this is like the one we looked at before where they just barely touch and they only have 1 point in common. That point has an x value of negative 1, and then to find my y value, I can plug it into either of these options. This will give me a negative 3. If I plugged it into the top option, negative 1 squared is positive times a negative 3 would be a negative still. So in both cases, these two cross at negative 1, negative 3. So if I thought that didn't seem right, I could check again on my calculator and just see if that actually is true. So in the first one, I have negative 3x squared. And then in the second, I have 6x plus 3. Whoops, sorry. I have no idea what I was doing. 6x plus 3. So here when I go ahead and graph these, I'm expecting them to just barely touch, which they do, and that it should be at negative 1, negative 3. So right here-ish, they seem to be grazing each other, and that's why that has one possibility. Okay, let's take a look at this last one. Have a little bit more complicated action here, but not really. So again, these are both y equals, so I can set the x minus 5, I don't really need parentheses, sorry, equal to this by plugging or substituting that in for this y. Again, it's a quadratic. That'll happen a lot. So I'm going to take this and move them over by subtraction and addition so that I have it equal to 0, which is necessary for solving these. That cancels, so that's a little weird. Here I'm going to factor, but I'm going to be factoring out the greatest common factor, which is an x. So in order for those to equal 0, x either has to take on the value of 0 or x has to take on the value of negative 3, which means up here, my two spots where they could intersect would have x values of 0, negative 3, and then again, I go back and plug them in to find out, and I'm picking the top one just because it's easier, to find out what the associated y's would be. So when you are turning in your work, the graphing won't have any, so that's fine, but the ones for substitution should look like this. A lot of you do kind of math magic and you copy the question and then you write down your answer. So that's not going to be an acceptable way to do these. I want you to just show the steps that you're doing. If you need to use quadratic formula to find yours, remember that's the opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a, and the place you get those a's and b's and c's from would be from the quadratic itself. It's going to be in this format, like we had here. So in this particular case, a would be 1 because that's what's in front of the x squared. B would be a 2 because that's what's in front of the x. And my constant would be -3. And if I plugged them in here, I would actually get the same answers, but for me, factoring is easier. And if it's not factorable, you're going to be forced to use quadratics. So that's kind of the worst case scenario. Keep in mind that you can have no solution, one solution if they disagree with each other. So you might have a parabola with a line and they never meet, so you're going to have no solution. You could have a parabola with a line that grazes it. Oh, good, barking. So you'll have one. Or you could have them cross in 2 spots. Seems like a good time to sign off, guys. Good luck. I'll see you later.